Hello everyone, today we are going to be comparing quadratic functions. And we're going to be kind of looking at characteristics of different functions and using those to compare different parts of them, okay? So we have found characteristics of functions algebraically by looking at an equation. We've also found them by looking at a graph. Something else you should be able to do is find characteristics by looking at a table like we see here. Okay, so if I'm looking at this table here and I want to know where the vertex is, okay, the vertex is going to be basically the middle point of this table. And do you see how this 4 and this 4, these are symmetrical? The 7 and the 7 are symmetrical. The 12 and 12 are symmetrical. The vertex is going to be halfway in between all of those symmetrical points. So our vertex would be negative 2, 3 on this example because it's in the middle and it's symmetrical on each side of that point. Okay, for the y-intercept, we know that something is the y-intercept where x is equal to 0. So look for x equal to 0, okay? And I'm gonna highlight this in blue so we see that. And we see that x is 0 right here. That is going to be our y-intercept. Our y-intercept is the point 0, 7. Okay, for x-intercept, what we're looking for is y is equal to 0. Okay, and if we look at this table here, y is never 0. And something else we also see is that it starts at 3, our vertex is at 3, and it actually goes up on each side. So this thing is actually never going to touch the x-axis. So this function has no x-intercept because y is never 0, okay? And then does this have a max or a min? So since our vertex is at 3 and it's going up on each side, this is the minimum value, okay? So this thing is going to have a minimum, okay? And that minimum is the vertex, which is 3. Okay, here's another example. Which axis of symmetry is further to the right? Okay, so I need to find the axis of symmetry of each of these things, all right? And axis of symmetry is just the x value of your vertex. We are going to find that right here on this function. And remember, it's always the opposite. So our axis of symmetry here is going to be x is equal to negative 4, all right? For k of x, remember, it's the x value of your vertex. So this right here is the vertex, okay, because it's symmetrical on each side. So our axis of symmetry is actually x is equal to 4. So if I were to put these two numbers on a number line, -4 is going to be to the left, +4 is going to be further to the right. Okay, so to summarize this, we're going to say that k of x has an axis of symmetry further to the right. Okay, here's one more example. It says if f of x is shifted to the right 3 and up 2, and g of x is shifted left 1 and up 7, which would have a higher maximum? Okay, so first thing we need to do is we need to find where the vertex is before we do the shifts that it's talking about here. Okay, so if I find the vertex, just like we did in that first example, we're going to do x is -b over 2a, and that's going to be -8 over 2 times -1, which is -8 over -2. So our x value is 4. We need the y value as well. So the y value, we're going to sub that 4 in. So -4 squared plus 8 times 4 minus 18. And that will be -2. Okay, so our vertex is for -2. Now, it tells us to shift it to the right 3 and up 2. Okay, so that just means if I shift something to the right 3, I'm going to add 3 to x, and we're going to add 2 to the y value to shift it up 2. So my transformed vertex is going to be this right here. We're going to have 7, 0. And the maximum value of this thing is going to be the y value that you see there. So the highest this thing ever goes is 0. Okay? So the next one, the vertex of that one, it's a little bit easier to find it because it's in vertex form already. Our vertex is the point -6. The y value is -8. Okay? So if we shift this thing to the left 1, that's just telling me to left 1 up 7. We want to subtract 1 from x. And this up 7, this means we're going to add 7 to y. Okay, so the transformation is going to take me here. We're going to have the point -7, -1. Okay, and again, this number right here, the y value, is your maximum. Okay, so the two maximums we have 0 and we have -1. 0 is a bigger number than -1. So we're going to say that the f of x function has a higher maximum. Okay, so today you should be able to just compare quadratic functions given different representations. If we're given a graph, an equation, or a table, you should be able to use those to compare. So please go check out the assignment that's on Canvas and let me know if you have any questions. Have a great day.